Well, hello and welcome back to APHA's 15 on COVID-19 series. I'm your host, Dan Zlot, and today we're going to be taking a look at COVID-19 variants, what they are and what they mean in terms of therapies and vaccine efficacy. So let's go ahead and jump right in. I have no disclosures. However, it's important to note that this project was funded in part by a collaborative agreement with the Centers for Disease Control and Prevention, looking to address vaccine hesitancy. Here are your learning objectives for today. So when we start talking about COVID-19 variants, there are a few things to think about and to know. So let's start off with some background info. So one of the first things to understand is that there are in fact dozens of identified COVID-19 virus variants out there, maybe even hundreds. However, not all of them are clinically relevant. In fact, only a few are clinically relevant. The CDC and WHO constantly and very closely monitor COVID-19 virus variants so that we can identify any potential issues as soon as possible. Now, the CDC has classified variants into one of several categories, and that would be variants of interest, variants of concern, and variants of high consequence. So let's talk about these in a little bit more detail. A variant of interest is one in which there's some low-level evidence which suggests that the virus may have increased transmissibility, may have the ability to evade diagnostics, or perhaps impact the efficacy of therapeutics like monoclonal antibodies, or potentially result in immune escape, whether that's from natural antibodies or from vaccine-induced antibodies. Now, again, these are sort of low-level evidence. There's not hard data out there. Now, when we move on to the variants of concern, these are variants where there's well documented evidence of one of those things. So either significantly increased transmissibility, the ability to impact the specificity or sensitivity of diagnostics, the ability to affect immune response. So whether, again, that's coming from a natural infection or from a vaccine-induced antibody response, as well as the ability to potentially evade monoclonal antibodies that have been developed against COVID-19. And then finally, we have the variants of high consequence. So these are clear evidence that preventative measures or medical countermeasures are significantly affected or significantly reduced in effectiveness compared to other variants. Now, fortunately, right now, there are no variants of high consequence that have been identified. There are a number of variants of interest as well as variants of concern that have been identified. Now, let's take a quick moment to look at the graphic on this slide. The graphic represents the currently identified variants of concern, and there's really four main ones. So that's alpha, beta, delta, and gamma. And the graphic shows the location that the variant was first identified, the approximate time frame in which it was identified, as well as the WHO classification. So again, that's alpha, beta, delta, etc. And we're going to be taking a closer look at each of these variants as we go throughout the rest of the presentation today. So as we start talking about the COVID-19 variants, why do they really matter? Well, first off, some of the variants can result in clinically relevant changes to the SARS-CoV-2 virus, also known as the COVID-19 virus. In particular, one thing that may change is that the virus may gain the ability to gain entry into cells more rapidly or more readily. And so that can result in a couple of things. First off is increased transmissibility, so it may spread from person to person more easily. Additionally, it may result in increased morbidity or mortality. So it makes sense that if the virus can get into cells more easily, you might have a lower dose required to initiate an infection. Alternatively, you may be able to more severely affect various tissues, which of course would result in increased morbidity or mortality. In other words, more severe disease. Additionally, you may see antigenic shift or antigenic drift, and so that can result in the ability to avoid immune detection. So one of the main tools that we've been using is vaccines to help prevent the COVID-19 virus. So there's a possibility that as the antigens change enough, the antibodies generated by the vaccines may not be able to recognize some of these variants. Additionally, we've also developed monoclonal antibodies against COVID-19. And so again, if the antigens targeted by those antibodies shifts enough, those antibodies may lose efficacy. And certainly we've seen that, and we'll talk about that as we go throughout the variants. Other things that may be affected are the effectiveness of COVID-19 testing. So some tests look at RNA sequences of the virus directly. They're looking for little snippets out of the RNA sequence of the virus. So if you get a mutation within a certain sequence, it may result in an RNA-based test, a PCR-based test, not detecting the virus. Additionally, if the mutation is significant enough that it results in an antigen shift or change, like we just talked about, an antibody-based test that uses antibodies to detect the virus may also lose sensitivity or specificity. So a couple different ways that you might see impact on testing as a result of variants. And so, as we just talked about, some of the mRNA and protein structure changes there and the implications of that. So when we start talking about the variants of concern in particular, let's start off by identifying what those are. The original virus is called the wild type virus. You'll commonly hear it referred to as the wild type. It does not have a WHO classification. It's just the COVID-19 virus. And it originated in China, as we all know. And because it's the wild type, it's sort of our baseline. So when we start talking about the impacts on monoclonal antibody efficacy or vaccine efficacy, it's not really applicable because it's the original, it's the comparator. So the next one is the B.1.1.7 variant, also known as the alpha variant that originated in the UK. And as we'll see, there's no significant impact on monoclonal antibody efficacy or vaccine efficacy. The next variant is the beta variant, or the B.1.351 variant, which originated in South Africa. And that one does have some impact on both monoclonal antibody as well as vaccine efficacy. And then the third variant is the Delta variant, which we are hearing a lot about right now, which is the B.1.617.2 variant, which originated in India. And this one is still early, so data here is a little bit fuzzy, so there's potentially some impact on monoclonal antibody, and right now we're not seeing a lot of impact, but there's still data ongoing regarding vaccine efficacy. And the final variant is the P.1 or Gamma variant that originated in Japan via Brazil. So it actually was identified in Japan, but it was identified in passengers from Brazil. And we definitely know that that impacts monoclonal antibody efficacy and may impact vaccine efficacy. Still some data ongoing there. So those are the variants we're going to be talking about in more detail. So let's dive in and actually take a closer look at some of the data. Now, when we talk about the variants of interest, so these are all the ones that the CDC is monitoring, not just those that are demonstrated to have significance. One thing to note is that this graph is a little bit busy, but it shows you the frequency of the different variants over time. And you can see on the bottom there the different dates starting in April running up through middle of June, and the proportions of the different variants that are seen in the US population. So this is a graphic that's coming out of the CDC. And what you can see here is that the alpha variant, the B.1.1.7 variant, is probably one of the most prevalent right now, making up about 43% of cases. And the Delta variant, as of June, is now making up about 31% of cases in the US. And so again, that's the B.1.617.2 variant. We see a little bit of activity in the P.1 variant, the Gamma variant, and it's making up about 10% of US cases. And then there's an interesting emerging variant called the B.1.526, also called the Iota variant, which is making up about 5.5% of cases in the US. That number is on the rise, according to the CDC. It has not yet risen to the level of a variant of concern. For now, it's just a variant of interest. So we will be keeping an eye on that along with the CDC to see what comes of that, as well as any properties or any impact on monoclonal antibody efficacy as well as vaccine efficacy. So now that we've taken a look at the variants of interest circulating in the United States, let's dive into the properties of the specific variants of concern that have been identified by the CDC. And we'll start off with the alpha variant. So the first thing we'll look at is transmissibility. And what we see is that it's about 50% easier to transmit the alpha variant as compared to the wild type variant. Additionally, we see more severe disease. So there's some evidence out there that suggests increased rates of hospitalization or case fatalities as compared to wild type again. And right now, there's no significant impact on the efficacy of the currently available monoclonal antibodies as compared to wild type. Now let's take a look at some of the vaccine efficacy data. So as we dive into the specific vaccines, we see that the Pfizer vaccine is highly effective, approximately 90% effective at preventing infection and almost 100% effective at preventing severe, critical, or fatal disease. Now, this data is coming out of Qatar, and it's important to note that this data is based on a patient population who had a mix of the alpha and beta variants. So it's not 100% alpha, but regardless, we can see that the Pfizer vaccine is highly effective. Some similar data also suggests that the Moderna vaccine is 100% effective at preventing infection, and we've got the references for you there in case you'd like to take a quicker look at that. Additionally, the J&J vaccine, J&J released a press release referencing this article, which was released in MedRx IV. And it's important to note that this is not peer-reviewed yet, so take it with the appropriately sized grain of salt. But in that reference, they demonstrate that neutralizing antibodies against the alpha variant were produced and are present 8 months post-vaccination. So that suggests that there's good immunity against the alpha variant produced by the J&J vaccine. And finally, even though it's not approved in the US, we as pharmacists are still getting questions from some of our patients about the AstraZeneca vaccine, so we'll touch on that as well. And what we've seen here is that it was 70% effective at preventing infection from the alpha variant. So with the alpha variant covered, let's go ahead now and dive into the beta variant. So when we look at the beta variant, what we see is that there is also increased transmissibility, 50% more easily transmitted as compared to wild-type virus. Here, the morbidity and mortality is very similar to wild-type. Early on, there was some suggestion that this might have been more severe in terms of the types of disease that it produced. However, more recent data suggests that it's very similar to wild-type. When we look at the efficacy of monoclonal antibodies, here we start to see some reduced susceptibility to bamlanivimab itself on its own, as well as the combination of bamlanivimab and etesevimab. So this combination is no longer recommended for beta variant, and in situations where beta variant makes up more than 10% of circulating virus in a certain locality, most of the time the government has been stopping distribution of the bamlanivimab-etesevimab combination. So let's talk now about vaccine efficacy again. So for the beta variant, we see that the Pfizer vaccine is pretty effective at preventing infection, about 75% effective at preventing infection, and almost 100% effective at preventing severe, critical, or fatal disease. Again, this is based on the same paper we talked about with the alpha variant. And as noted, this population contains a mix of the alpha and beta variants. So it's not 100% clean in terms of the breakdown by variant. But regardless, the Pfizer vaccine demonstrates really good efficacy against the beta variant. The Moderna vaccine was also 96% effective at preventing infection from the beta variant. So high effectiveness, high efficacy rates from our mRNA-based vaccines. When we take a look at the J&J vaccine, this is coming out of some of the early data, which contained a high incidence of the beta variant in their population, particularly in their South African population, where almost 95% of the infections in the South African population were from the beta variant. And so what we see is that the J&J vaccine is about 80% effective at preventing severe or critical disease in that South African population. And finally, just a touch on the AstraZeneca. This is one area where we've actually seen a failure of the vaccine. The AstraZeneca vaccine was deemed to be not effective against the beta variant. Now let's move on to our next variant. So the Delta variant has increased transmissibility compared to wild type, although the specific rate has not been identified yet. So still looking to see how much more transmissible it is as compared to wild type. In terms of the impact on morbidity and mortality, this is relatively new, so there's some data out there which suggests that it has increased morbidity and mortality. There's also some data out there that suggests that it's the same as wild type. So I think we need more data before we can draw any firm conclusions about the severity of disease produced by the Delta variant. With regard to monoclonal antibody efficacy, again, because this is relatively early on, we don't have quite as much data as we would like. we're seeing potential reduction in efficacy compared to wild type, but it has not been fully confirmed yet. So still need to have a little bit more data before we can draw solid conclusions there. As we start looking at the vaccine efficacy, we do have some good news here. So looking at the Pfizer vaccine, the Pfizer vaccine was 88% effective at preventing symptomatic disease and 96% effective at preventing hospitalization. And so again, this is coming out of medRxiv, which is not peer-reviewed, so take it with the appropriately sized grain of salt. The Moderna vaccine, still more info needed. However, there is some early evidence out there that it's effective as well, but have not seen formal publications related to that, so we'll reserve judgment until we actually see some formal scientific write-ups. The J&J vaccine, so again, this is coming out of an article that's not peer-reviewed, but this suggests that there are neutralizing antibodies against the Delta variant produced by the J&J vaccine, and that those neutralizing antibodies are present 8 months post-vaccination, which again suggests that this should be able to prevent infection and severe disease. The exact efficacy again at preventing infection and at preventing severe disease still to be determined. And finally, for AstraZeneca, some data here suggests that the AstraZeneca vaccine is about 60% effective at preventing symptomatic disease from the Delta variant. And symptomatic disease is not the same as severe disease. So symptomatic disease is just an infection that causes symptoms. So still, I think, more data there before we can really draw firm conclusions, but early data suggests that the AstraZeneca vaccine is effective. Now let's move on to our final variant that we'll be discussing today. So the Gamma variant. The transmissibility of the Gamma variant is similar to wild type, so it doesn't appear to be much more transmissible, and I think that's why we see a relatively low proportion of this particular variant circulating in the population. In terms of the morbidity and mortality, or the disease severity, it's also similar to wild type. However, one of the early things that they identified with the Gamma variant is that it does have the ability to escape immune detection, particularly antibody detection or antibody recognition. As a result, we see reduced susceptibility to bamlanivimab as well as bamlanivimab-etesevimab combination. So in any area of the country where you have more than about 10% of the Gamma variant in circulation, you will not see bamlanivimab and etesevimab distributed by the local government to help address patients who would qualify for monoclonal antibody therapy. When it comes to vaccines, we see that it's interesting, there's not a lot of data out there, even though this is one of the older variants. So what we see primarily is based on neutralizing antibodies. So here we see that the Pfizer vaccine is able to generate neutralizing antibodies against the Gamma variant, and that those antibodies are present starting at about 4 weeks post-vaccination. Similar, the Moderna vaccine, we see neutralizing antibodies against the Gamma variant, and that those antibodies are present 1 week post-vaccination. And when we say post-vaccination, that's completing the full series of both shots for both the Pfizer and Moderna vaccines. For the J&J vaccine, again, this is coming from a non-peer-reviewed journal, so just want to make sure that you understand that. And their data suggests that neutralizing antibodies against the Gamma variant are produced and present 8 months post-vaccination. And finally, for AstraZeneca, we see that neutralizing antibodies against the Gamma variant are produced and are present 4 weeks after vaccination. And again, the AstraZeneca vaccine is a 2-vaccine or a 2-dose series. So that covers all the details of the particular variants, what we know about vaccine efficacy, as well as monoclonal antibody efficacy, transmissibility, and of course, disease severity. So now let's talk about the bottom line. So, as we discussed, COVID-19 variants have the potential to impact the efficacy of monoclonal antibody products for COVID-19, particularly bamlanivimab and etesevimab. They may impact the ability of some tests to detect COVID-19 as well as COVID-19 antibodies, and the FDA actually has a good list of which tests in particular have been identified to have issues with certain variants. So do check out the FDA's website for more information there. Most importantly, COVID-19 variants are likely to continue to develop and evolve as long as COVID-19 is circulating amongst the general human population. So the best thing we can do is to continue to vaccinate people so that we can stop the development and spread of these variants. We know for sure that the COVID-19 vaccines that are currently authorized in the US are effective against the currently identified variants of concern, alpha, beta, gamma, and delta. We also know that they're the best way to prevent the development of additional variants. Now, it's important for us as pharmacists to be out there addressing vaccine hesitancy, addressing the concerns of our patients who are concerned about the vaccine. And what we're seeing now is a perfect example of why this is so important, where we see these localized hotspots of COVID-19 infection, particularly with the Delta variant, and it's almost always in patients who are unvaccinated. And hospitalizations are overwhelmingly, more than 90% of hospitalizations are resulting from patients who are not vaccinated. So incredibly important for us as pharmacists to get the word out there. So that will wrap up today's episode of 15 on COVID-19. We hope you found this enjoyable and helpful, and stay tuned for our next episode, which will be addressing the need for booster shots against COVID-19. We'll see you then.